Most welcome. Most welcome at this first session of Getting Live after of the second season. The subject is what is machining economics and why should you care about it? That's the subject of today, and I should tell you that this is a subject which is so wide, so big, that also the next episode in this second season we will continue with this same subject. So, machining economics. What is it and why is it so important? My name is Patrick de Vos. I'm your host of today, and my how to say, the thing I like a lot is machining. Machining as a manufacturing process, and especially take it from a scientific perspective, so you don't have the chaos factor in machining. Because that's very often the case with machining. You know, things are happening and people do not know why, and it's chaos all over. I have been spending more than 40 years trying to understand machining in a scientific way, but not just machining as a technology, because machining is something with two faces. You know, you have the technological side, and that's fun. Ooh, machining is so much fun. But machining also serves, how to say, an economical target. Machining is something that is done in the industry to produce workpieces. Workpieces with what companies have an ambition. So it's machining from a technological perspective that is for me very, very nice and very amusing, but it's also machining as an economical activity that intrigues me, and that is the subject of today, really. How can we see machining? How can we discuss about machining from a technological perspective? Next, also from an economical perspective. And I'm not alone here. You know, these events, we have a whole team. Olivier from France, Vijay from India, and Alesia from Italy. They are the people in the background, the people, taking care of all the technical stuff, so I can do my thing here. And before we start, I would like to start with some typology, because in machining, especially today, we talk about a lot of things and a lot of notions, and sometimes people don't know anymore what is what. What exactly are we talking about? So the first thing I want to do is discuss a little bit about the wordings we use when we talk about this, and what exactly do we mean with it. The second big part of today's session is try to define the circumstances, the conditions which we need to be able to lift machining from that pure technological level to that more economical level, where we start to talk about economics. But first, let's try to define machining economics. Machining economics is a word that is applied to a group of optimization scenarios which are associated with machining processes. And with like all optimization scenarios, it's important to define the criterion that we want to optimize, that we want to minimize, that we want to maximize, and define it as a function of factors, given elements, and variables, variable things we can work with, that we can control in the machining process and in the machining system. Important when we talk about this is to define how narrow or how wide we define the domain in which we are going to work. If we say, okay, we want to optimize, let's say we want to optimize time. Time is our criterion. When we optimize time in machining, normally we use the word productivity then, but I come back to it. So we want to optimize productivity. In the background is time. Now, if we talk about time, we need to define which time exactly are we talking about. Are we talking about the time in cut, the time a tool is in contact with a workpiece and machining is being done? Or do we talk about time in terms of the time needed to produce or to finish a full operation, also included all the times around the process? Or do we define time as a more company-wide thing, the time that the customer is going to wait for a finished product after he made an order? So, how narrow, how wide do we talk? And that's a very important thing to consider when we talk about machining economics. It's crucial in such a way that it avoids that there are misunderstandings between what we talk about. So machining economics, a group of optimization scenarios, and just below it, and that's something I would say it's from the last years, we start adding things like we can talk about smart and sustainable machining. And smart and sustainable machining is one way of looking into optimization. And another thing people use in this context is the term digital machining. Now, has digital machining something to do with machining economics? Yes and no. Digital machining is more a methodology we could use to work within the machining economics domain. So those two are a bit, they are connected, but it's difficult to define exactly what we mean with it. But I come back to those two more in specific a little bit later on. On a more technical level, if we talk about machining economics, there are the technical approaches. Technical approaches, I refer to that within machining economics, the different scenarios we could use to optimize could be labeled economic machining, where we optimize profitability, could be labeled productive machining, where we optimize time. And again, remember what I said a couple of minutes ago, how narrow, how wide do we define things here? We could talk about trouble and waste-free machining, where we optimize process and part quality, workpiece quality. We could talk about resource-efficient machining, where we optimize the usage of the equipment, where we optimize the consumption of raw materials. We could talk about energy-efficient machining, which is yet another strategy, another way of working within that broad economics perspective, where we basically optimize energy consumption, a very important thing in present times, I think. And we can talk about the old word we use is green machining. Green machining is a word we use since middle of the 80s, where we talk about the ecological impact of a machining process. So it's different scenarios we can pursue under the umbrella of machining economics. Now, perhaps interesting, each one of you here, if you look to these scenarios, economic machining, productive machining, trouble and waste-free machining, resource-efficient machining, energy-efficient machining, and green machining, which one do you think is for you the most important one? Which one do you use mostly? And put this in the chat, in the comments here. I gave each of them a letter, A, B, C, D, E, or F. It's interesting for the later part in this presentation to have an idea about how you in the machining industry look on these things. So just put a letter in the chat and we come back to that. Now, as I said, a few thoughts on those words we use in this context, sustainability. Now, sustainability is a word everybody's using nowadays, and I have sometimes an idea we lost a little bit focus here. So I think it's time to simplify a bit. And simplified sustainability is about matching the needs of the present generation, being it people or societies or companies or industry, whatever, without compromising those of future generations. That's you know, lots of people give long thoughts on this, and this is perhaps the simplest, hence the best understandable definition of sustainability. Doing things today in such a way that the needs of today are fulfilled and the needs of the future generations are not compromised. That's what it's about. And if you think on that, sustainability, so how to do things today, there are different accents we can put. We can talk about economic sustainability, social, moral, ethic, trade, geopolitical, resource, energy efficiency, ecological sustainability. That's the one which is most in the news nowadays always. And I can put them a little bit around the machining process. And if we say, okay, sustainable machining, what is it about? It's about cost and time efficiency. That's a potential approach. It could be about energy efficiency. That's another approach. It's about people friendliness. People working in the machining industry should not be frustrated, let me put it like that. Frustrated due to issues, problems, impossibilities that they have to deal with. People friendliness, perhaps a very strange thing to put it with a machining process, but those working in machining, I think, understand exactly what I mean with this. Machining should be effective, no waste, resource efficient, eco-friendly, the environment. So it's different accents we can put under that sustainable machining thing. Smart, because often the two are combined, smart and sustainable. Smart, for me personally, I express a little bit here my own personal feeling about it. Smart is doing things in such a way, whatever your ambition is, one of these six, smart means achieving your ambition with the lowest effort, with in the easiest possible way. Here again, perhaps I would like to know your ideas on this. If you think on this, if you think on your company, if you think on your workshop where you work, out of these six, which one is for you most important? And I know everything is important, but yeah, there can be only one priority. Which one would you select? And again, put it in the chat, please. We pick it up later on. Is it 1, 2, 3, 4, 5, or 6? Which is for you the most important one? Because this has consequences. Depending on where you put your accent, there are slightly different approaches. Today, as we have limited time, I cannot deal with everything. But today we decided, when we were discussing this, in preparing this, we decided, okay, let's focus for today on cost and time effectiveness. And it's a choice, you know. If you bring all the other 5 into the picture, in the end, it leads always to that if you manage to be energy efficient, if you manage to be people friendly, if you manage to be effective, if you use your resources in an efficient way, and if you think on the environment and do necessary things not to destroy it, you will be cost and time effective if you look on things from a company-wide perspective, not just from the machining process perspective. Now, how can we make it happen? It's all very nice to say, okay, sustainability is for us a very important thing. And under that sustainability, we want to do things in a smart way. We want to consider a digital approach to do things. And we want to use some strategies and so on. Now, what I want to do today with you is step by step, say, okay, to make it possible, to make it happen, there are some prerequisites, some things that needs to be in order. Today, and we are in the second part of this presentation now, today I want to give you 5 important chapters that needs to be taken care of. And if that is okay, then we can really start to work with economics. But that is for the next edition. And end of next month, we will talk about in a situation, yeah, we have the environment now, things are in due order, okay, how can we work with things? So step by step, and the first step, most important step, is that you have to understand machining in a little bit more scientific manner than just the chaotic approach, you know. With the, and chaotic sounds a little bit negative, I know, but you know, very often in machining, throughout the years, I experience it so often that people are confronted with a situation, they do not really understand what is going on, and then they start to trial and error, try this, try that, and if you do that long enough, sooner or later, you'll find something that seems to work. I think that's not good enough. You know, if you want to be on top of things, also from an economical perspective, it's not enough to know what to do to solve a certain thing if it's becoming an issue. You need to know why. I do this, and why do I do this? And what will be the consequence if I do this? And so on and so forth. And that's what I mean, that we have to see machining is a physical process. It's an interaction between a cutting tool and a workpiece. And how the interaction takes place is influenced by the features of the cutting tool, the blue part here in this picture. You have a certain cutting tool with certain features, and that gives you a tool with certain possibilities. On the other hand, that tool is going to work in a certain environment, is going to have to do a certain machining process of a workpiece, and that environment, that workpiece, is going to create loads that are going to act on a tool, the gray part here in the picture, the part to the left. There are different elements, different variables, different factors coming from the machining environment that are going to influence how the interaction takes place. And that interaction, understanding it, describing it, controlling it, that's the part in the middle, the red part. There we will have to understand that there are mechanical aspects to this interaction, there are tribological aspects, there are chemical aspects, and so on and so forth. Understanding machining is understanding this scheme here. What are the features of a cutting tool which are important because they influence the interaction? What things from the environment in which I do the operation do I need to bring into the equation to make sure that no unforeseen things happen? And if I evaluate the interaction, they are the different approaches I need to evaluate. Because if you have vibrations, that's a mechanical phenomenon. If you have surface quality things, that's a tribological thing. So it's different things we have to understand here. Although that is a scientific approach, the evaluation in the end, if you have been working with this and if you created a situation and if you think, okay, is this good now? The that evaluation is a more pragmatic evaluation. That evaluation, we have been developing, what should I say, measuring tools, measuring approaches, methods that will tell us if we solve this machining equation in the correct way. There are two tools I want to draw your attention on. One is what we refer to as GTDA, Global Tool Deterioration Analysis. With other words, look at your cutting tools. Your cutting tools tells you what happened during the machining process. The other thing I would say is listen to the people. Listen to the operators, listen to the machining experts. They have a feeling for a process, and they also will give you their sometimes subjective, but anyway, subjective approaches in machining are not always bad, you know. And that's the process. And if you master that, if you control that, if you are capable of making a process reliable, and reliable means that it delivers what is expected, which is a correctly finished workpiece, the next thing then we can do is we can start talking about the economical side. We can start talking about optimizing times or costs or whatever. So step one, if you can describe a machining process in one solid and consistent physical model, it's possible to start talking economical about the machining process. Because if we want to compare different scenarios, not only from their technological perspective, but also economical perspective, we have to master the process. We have to be capable to, and the keywords here are, to create a reliable, predictable, controllable process. Now, that is possible, but there is one element that is crucial in this, and that's the cutting edge. And I use on purpose the word cutting edge and not cutting tool, because the thing which is in contact with workpiece material, actually doing the machining, is a cutting edge. A cutting tool is the equipment behind the cutting edge that supports the cutting edge in its machining process. Smart tool selection, and we have been spending a previous session on smart tool selection, but smart tool selection, and here is the word smart again, and it's very important that smart, you remember smart, minimum effort, minimum issues, minimum problems, yet achieving the main targets. Now, smart tool selection must be in line with the overall company KPIs. I made the statement before that smart tool selection is something which is I see it as a management task. A little bit, again, yeah, it's my way of saying smart tool selection is too important to leave it in the hand of technicians. Technicians are the ones that has a major responsibility later on in solving, in answering all the technical things. But depending on what the company stands for, stands a company for productivity, or stands the company for economy, the costing, you know, or stands the company for quality, or is versatility, think on small batch production, a major KPI for a company? Well, each of these four basic approaches leads to a specific choice of a tooling system. If you go for productivity, you need a tooling system that performs extremely well. If you go for economy, on the other hand, you need tools that are, from a money perspective, the usage of it should be as low as possible from a cost perspective. If you go for quality, you need quality tooling. You need tooling with sustainable cutting edges, reliable cutting edges. If you go for versatility, you need tools with a broad application domain. And this is a choice that needs to be done before you start talking about technical stuff, like carbide grades and geometries and stuff. This comes first. Again, interesting for the interaction a bit here. If you think on tools in your company, where do you put the accent? What is for you important? Is it performance? Then you can put in the chat a P. Is it economy? An E. Do you say no? Quality is my standard. Then it's a Q. Or do you say no? Seeing my type of production, versatility is my priority. I need tools with wide application domain. And let there be no misunderstanding. Each of these four is good. It's not about bad or good here. It's four different approaches. But it's a choice that needs to be made. Because if you fail to make this choice, you end up in total disorder in the workshop when it comes to tools, tooling, people using the tools, and so on. Basic, important choice to take. Step 2, make sure that the tools you selected are as much as possible in line with the overall company KPIs. If that is done, if that is thought over well, then tools will support in a smart way cost and time efficiency, economical sustainability. And tools in that respect, again, and I take point 1 now again on board, tools must support trouble-free machining. Yeah? That is very important. So I understand machining. That is my foundation. I understand machining from a scientific perspective. I know what to do, how to control, how to predict, and so on. Second thing is, I have been thinking very wisely about my basic tool selection. Should tools be supporting productivity goals, or economical goals, or quality, or versatility goals? Third thing is, know your playground. With the tools you have been selected, know what is possible to do with these tools. And this is a bit about knowing the limits, knowing the borders. Because if you look from whatever tool, in the beginning, everything is possible. Each time we launch a new tooling system, and the initial message is, this new tool can do everything. Nice, good, smart. And then the reality hits in. And then suddenly we start to realize that from a technical perspective, from a technological perspective, there are constraints. Because you know, that tool that can do everything, yes, very nice, but we have to make sure that the ship formation is good. We have to make sure that the tool do not break too much. We have to make sure that the temperatures are kept within certain limits, and so on and so forth. And suddenly we start from everything to go to a realistic domain of cutting conditions. The graph you see here to the left is a simulation how certain realistical constraints, practical constraints, will limit the choice we have in cutting speeds, feeds, and depths of cut. And knowing your domain, I mean with that, know your playground. You should know this thing. You should know, what can I do? How far can I go with cutting conditions? Now, but to continue to talk in this visualization here, within this volume of possibilities where everything is under control, there are 1 million possible combinations of cutting conditions. You can combine cutting speeds and feeds and depths of cut. There are 1 million combinations. Which one do you select then? And the moment you start thinking that, that's when you start going from machining the technological side into machining the economical side. Again here, there are basically 3 kind of strategies which we can use here. You can show a tendency to think in terms of, I want to go for the bigger depths of cut, or I think in terms of we go for the bigger feeds, or we think in terms of we go for the higher cutting speeds. And you know, these things you know about. I'm talking here about so-called high-speed machining, high-feed machining, high-performance machining. That's what I talk here about. Each time when a new tool arrives on the market, people talk, it's about, yeah, this is a high-speed tool and this is a high-feed tool and whatever. But make sure you have your sequence okay. Eh? You decide first what you want, and second, you must make sure that the tool performs in what you want. Again, for me, interesting to know what has your preference. If you think in terms of machining from an economical perspective, also do you like high feed machining? Here the letters HV you can put in the chat. You have F, the high feed, HV, the high speed approach, or HP, the high depth of cut approach. Would be interesting to know your opinion on this. What do you think has your preference here? And you can write if you want a little bit about why you prefer certain methods. So know your playground. Know the borders, know the limits. To be able to know them, you have to have the scientific insight in machining, otherwise you cannot draw the lines. And second, perhaps more difficult, have the discipline to respect the borders. I hear so often people know that there is a limit, yet they try to go beyond the limit. And then after a while, they are a bit surprised. They say, "Oh, I have problems." Yeah, if you don't respect the borders, yeah, you end up in a difficult situation. Now, we are ready to make the jump towards economic machining. Don't confuse machining economics with economic machining. Eh? Machining economics is a collection of scenarios. And there are all kinds of scenarios, the sustainability things, you know. You can say, I want to optimize the time, I want to optimize the cost, I want to optimize quality. That's all the different scenarios. Economic machining is within these scenarios. Remember one of the first slides I showed you. Economic machining is about optimizing costs and time, optimizing productivity, and the costs related to the process. Now, understanding this, and this picture will be the starting picture for the next session, and then we will jump into details based on this picture. If you look to the horizontal line here represents cutting conditions. A combination of depths of cuts, feeds, and cutting speeds, because that are the variables now. The rest became factors. Eh? The tools have been selected. Management have been thinking on which type of tools do we want to see in our company, which type of tools fulfill our basic needs or targets, whatever you want to call it. And next comes playground. You have been selecting the borders or defining the borders where you have to stay within. And within then, and now I start to talk about machining experts step into the picture. Which combination of cutting conditions do we go for? And the general picture is that if you go for higher cutting conditions, and why would you go for higher cutting conditions? Yeah, to increase your metal removal rate, to increase your productivity. But there is a consequence from an economical perspective. The consequence is that your tooling costs go up. And people familiar with machining know the reason. If you increase your cutting conditions, your tool life goes down. And if your tool life goes down, you need more cutting tools to do the same job. And that increases your costs for tooling. On the other hand, the costs for the machine equipment go down. If you increase your cutting conditions, the work will be done in a shorter time, and that means that the cost you need to bring into the calculation to cover the machine goes down. These are the two variable costs. And variable, I mean with that costs that change when the cutting conditions change. Next to this, of course, you have a lot of other fixed costs, but we are going to talk about that in the second session. The material costs, the fixing costs, the setup costs, all of those things are basically not influenced when you change cutting conditions. So we leave them for today out of the equation, but next time we bring them back in. Here, just for the understanding of it, we only work with variable costs, costs that change when I change cutting conditions. The two together gives me the total costs related to a machining process. And what we see here is that this yellow line, perhaps not so visible, but still, the yellow line is not a straight line, it's a curved line. If you think in terms of productivity, the time needed to do a certain job, what we see is that if you increase your cutting conditions, indeed your productivity goes up. That's why we increase our cutting conditions. But not forever. Somewhere there is a set of cutting conditions where the line turns around and you lose productivity. Why do you lose productivity? Despite you increase cutting conditions. But when your cutting conditions are too high, your tool life is going to become very short. And you need to stop often to replace the cutting edge. But that takes time. And the theoretical time you could gain by increasing your cutting conditions even further, you lose because the time you need to replace cutting edges is increasing very fast. That means that there is somewhere a set of cutting conditions that gives you maximum productivity. It's not the highest possible cutting conditions. It's a certain set of cutting conditions. There is also somewhere a certain set of cutting conditions that gives you minimum cost. Now, these two things will be the subject, very concrete, for the next session next month. How do I find these? Where are they? What is the set of cutting conditions I should use to have minimum machining costs? What is the set of cutting conditions I should use to have maximum machining productivity? That is what I call having insight, understanding from the economical side of machining. Having insight, knowing how to do that I have the best possible balance between cost efficiency and time efficiency. And that balance is what we aim for with what we refer to as economic machining. Economic machining is a smart and sustainable concept. Smart, as easy as possible, that's my definition of smart, with minimum effort to achieve still my target. Sustainable, doing it in such a way that it fulfills today the needs, but it respects the needs for future generations. It's an approach where we balance as good as possible cost and time. Still open in this discussion is, you remember the thing I was emphasizing so much in the beginning, how wide do we see this? Do we bring into in consideration only the machining process, and do we close our eyes for the environment? Or do we say, no, that's not realistic, because we know that the machine is going to stand still now and then to do setup of new workpieces because there was a technical problem. And while the machine is standing still, that costs time. That costs money. So perhaps looking just at machining is perhaps not the smartest thing to do. We should widen a bit our scope. But again, that's for next time. But for today, I leave it as a question. I leave it as something for you to think on, to reflect on. How wide do I see this? Once you start doing this, the fifth thing is here, and here the experts have to step in. Here we start talking about machining strategies. which is going, for your information, because this season we have quite a lot of interesting subjects. The strategies, the machining strategies. How are we going to do the machining? And within the machining strategies, how are we going to define our cutting conditions so that they fulfill both technological demands, we want to have a reliable process, my playground, and economical demands, cost efficiency, time efficiency, whatever. We started to talk about machining economics, a collection of scenarios to optimize. Optimization is good, but we need to discuss what we want to optimize. And once we define that, we need to define factors, we need to define variables, and run the optimization scenario. This means creating an environment where we can work in a good way with machining as a manufacturing process in such a way that it fulfills the economic targets of the company doing the process is 5 conditions. Condition 1, you have to understand machining more than just I'll try and see what happens. You have to have that physical insight in what exactly is happening. And the 4th step is about economic machining, the same insight, you know, the same understanding. What exactly do we mean now with economy? These 2 steps is about knowledge and insight. These things, how to say, you can learn. There are courses to learn this. It's knowledge, it's insight, understanding. Tool selection. Smart tool selection, so to make sure that tools are in line with the company KPIs. This is a little bit more about expertise, experience, because you know there are millions of tools. Millions combinations of carbide grades and geometries and tool systems and diameters and lengths and whatever you want. Millions. And if you want to do a theoretical approach, you're gone forever. So here it's, and this is the challenge, I think, for digital machining, to try to capture this expertise, this experience that is living in the machining world. How do I select my tools? The 3rd and the 5th step. The 3rd step, know your playground. The borders, the limits, and stay within. And the 5th step, think wisely about, is the strategy going to support my ambition? Are the cutting data going to support my ambition? This is, again, insights and skills. Here, with skills, I mean it's about having the ability to evaluate cutting tools. If you look to a cutting edge, that you recognize what you see, and that you can learn something from it. So 5 conditions to make sure that this picture of smart and sustainable machining, we can start working with it. Before I forget, now coming Wednesday, we have the ITI Day Aerospace. I have the honor to have a short presentation there also on machining of superalloys. And you see parts of this presentation I'll bring back into the picture, but very specific then for superalloys. But on the other hand, I would like to tell everybody, to invite everybody, if you have not yet registered, to register. It's going to be quite an adventure. It could be the first hybrid event ever in this domain. With hybrid, I mean it will be both physically and digital. It's a combination of 2 channels. And now it's question time. I do not know. Normally, I should have by now the questions. Let me see. One question is, I I was expecting that was going to come. What has sustainable machining to do with people friendliness? Now, that sustainable machining must be people friendly. I mean with that in machining, a big thing is people, the operators, the production engineers, the experts. And when you talk to those people, and if you look to machining as a process, it's so often a bit old-fashioned. It's try this, try that. People recognize easily issues, problems, but then taking them out, solving the problems, people do not always receive help, practical help. It's about, I don't know, try. And that gives frustration. Because machining people, machining operators, they are rather proud people. They want to do a good job. But if they don't know how to do, of course they get frustrated. And that's what I mean with don't underestimate that factor, that element. People friendliness is for me a very important thing when you talk about sustainability in machining. Then somebody, not really a question but a remark, that when you talk about strategies, technological strategies, high performance, high feed, high speed, that very clear approach is often not possible. It's very often a compromise between things. And I agree with that, because you cannot define that one set of cutting conditions that's going to give you absolute the best possible. It will always be a bit, I would like, but I know that, and that, then you have to find a compromise. Another question is about why do machine costs go down with increasing cutting conditions? Now, a very good remark. First of all, we talk about machine costs here, not machining costs. Machining cost, if we limit ourselves to the variables, the variable costs, machining cost is machine cost plus tool cost. The cost related to the machine tool I use to do the operation. Now, normally machine costs are expressed in hourly rates. People say, okay, a machine costs per hour she is in production, costs 50 or 100 or 200, whatever coin unit. And then if you look to the job that needs to be done, to the workpiece that needs to be produced, that workpiece is going to be on the machine, let's say, for half an hour. And that means in the cost for that one workpiece, I need to put in half an hour machine costs. Now, if I increase my cutting conditions, that means that the job will be done faster, that the workpiece is going to be shorter on the machine than half an hour, and that means that in the price of the workpiece, the cost for the machine will be lower. I think I understand the background of this question, because people sometimes confuse machining cost and machine cost. It's two different things. Then there is also, wait, let me read the question. It's about calculating the best combination of cutting. Yeah. It's a question, a rather intriguing question, because indeed very often in workshops people confuse a bit. There is, let me say, a legend that says that if your tool life is longer, that is better for your costs. Because if your tool life is longer, then you need to buy lesser tools to do a certain job. And if you buy lesser tools to do a certain job, then your costs are lower. Now, this is a very typical example of what I said in the beginning of the presentation about where do we focus on? How wide or narrow is our focus? Because if your focus is only tooling costs, then indeed, if you use lower cutting conditions, you need lesser tools and your costs go down. If you would increase your cutting conditions, your tool lives will be shorter and you need to buy more tools and your costs go up. Tooling costs. If you look to machining costs, however, if you lower your cutting conditions to reduce your tool costs, you are going to need longer time to finish the workpiece. That means that in the price of a workpiece, you are going to have a lower tool cost, correct, but at the same time a higher machine cost. Let me give you a concrete example. If somebody says, costs are important for me, tool costs are important, which cutting conditions should I use? Well, my answer is you should use cutting conditions, cutting speed 0, feed 0, depth of cut 0. Your tool life is going to be forever. You don't even need to buy tools anymore. However, the production guy will be very quickly at your machine asking you what you are doing because your productivity just dropped to 0. You don't produce anything anymore. If the if the production guy says productivity is for me extremely important, well, the advice should be use a high cutting speed, a high feed, and a high depth of cut. The higher the better. In theory, you will have high productivity. However, if you do that, very quickly the purchasing manager will be at your machine asking you what you are doing, because the consumption of cutting tools is going to increase dramatically, and his purchasing budget for tools is killed within a week. So, combining now extremely low cutting conditions is not a good thing. Extremely high cutting conditions is not a good thing. If you widen your vision, your scope a bit, it's a certain combination somewhere in the middle. So be careful with saying, making statements about long tool life, short tool life is good for costs, is not so good for cost. It's all depending on how you see your scope, how wide you define your scope. There are more. Yeah, we have time. There is a question here. How can we take care about the knowledge level of the people who are working in the metal cutting industry? Because the best tool or machine doesn't help if the people can't. Of course, that's you know, that's my personal passion. I told you in the beginning, a passion of mine is machining. As a scientific thing, as a physical process. I want to understand that thing. Another passion of mine is the economical side, make sure machining supports the economical targets of the company that uses it. The third thing, my third, perhaps biggest passion is people. Sometimes people ask me, what are you doing at Seco? I say, I teach, I'm a teacher, you know. Because you can have the best possible tool in the world, the best machine available, but if the guy operating it, if the guy using it doesn't know what he's doing, it doesn't serve any purpose whatsoever. And I don't know from who this question comes, but this is somebody with really insight in things, you know, because. Let me give you a personal answer. As I said, I'm 40 years in machining, or more than 40 years in machining. Well, if I want you give me the best milling cutter in the world, I kill it in 5 seconds. If that is what I want to do. And give me a milling cutter which basically is not perhaps the best choice, but I'm capable of making it work also. Knowledge of machining people, being it operators, being it engineers, being it programmers, whatever, but knowledge, skills is so important. Perhaps more important even is motivation, because knowledge we can give. We do regular courses for customers or for people in the machining industry in general. where we share the knowledge we have on machining and tooling technology. So knowledge is available. Skills is about practicing, training. You know, like sports people, they know what to do, but they have to train, they have to practice to increase their skill level. And yeah, motivation. With the motivation, I go back now to my people friendliness in sustainable machining. This is, I think everybody in machining with a broader responsibility should invest in people. Next to investing in machinery and hardware and tools and so on, invest in people, their knowledge, their skills, their motivation makes. Everybody says GTDA, you know, the global tool deterioration thing. People say, can you teach me? Yeah, of course I can teach you. It's not a big thing. But if you want your people to do that, you need to give them also a little bit equipment. I mean a magnifier glass and things like that. So it's about knowledge, it's about skills, it's about giving your people the equipment they need to do their job, and that will create motivated people, and then you have people-friendly machining. Sorry, I'm as I said, this is my passion, people and the knowledge. I see in the meantime we come close. Yeah, okay, perhaps one more question and then we should come to a conclusion. What would you recommend for people who are beginners? Because it's really important to understand machine learning. Start with education in machining physics, applied machining physics, that people understand the process. That comes first, and whatever level, practical level, theoretical level, but we should start by giving people insight in what it is that we refer to as a machining process. What is it? What is happening? What are the phenomena? If you don't understand or if you don't have insight in those phenomena, to what would it lead? What problems? If somebody says, I have a lot of problems with vibrations and I don't know what to do, well, give him the knowledge, give him insight. Is what is causing vibrations in the first place? And if you have that insight, then the solution when those vibrations are a problem is easy. So for me, it starts with knowledge. And if you know the whys, then you can ask what to do, and then you can start practicing to gain the skills. And the more knowledge you have, the more you have your skills fine-tuned, the more you are motivated to work with. That's how it worked with me, you know, all these years. But now we have to come to a conclusion, because perhaps you noticed, I should have said in the beginning, that this session was 15 minutes longer than the first season, because we have the subjects we have for this season are rather wide. And that's why we decided, okay, we need a little bit more time to bring a picture that makes sense for you. That's why the sessions in this second season are 15 minutes longer. The next session, we start again with what is economic machining. Basically, we already know it now. Economic machining is one of the scenarios under the umbrella of sustainable machining. Machining economics is one of the scenarios that could be, well, the leading scenario to make machining really sustainable and smart. So, but I want to repeat a bit next time, what is economic machining? And how can you benefit from it? Well, if you understand this, what can you do with this? What advantages can you draw from this? So I'm looking forward to see you at the next session, that we can continue this story together. In the meantime, I hope this made good sense. It was a bit general, but important yet to sketch the environment in which we can work. Know your machining process, understand your machining process, think wisely about the tools you use in general lines, the big concepts. Know your playgrounds. Understand the relation between machining and the economical, machining the technological side and machining the economical side. And make sure whatever machining strategy, technical strategy, high feed, high speed, all that type of stuff, and your final selection of cutting conditions is in line with your ambitions. That's, in 30 seconds, the picture I wanted to sketch you today. Next time is, as I said, okay, if we say we have this, we realize this, now we are ready to play. Now we are ready to work with it. Now we are ready to benefit from it. Thank you very much, and looking forward to the next session together with you.